This video is going to cover Stats 1, Section 1.3 on frequency, frequency tables, and levels of measurement. So levels of measurement, different data requires different ways to measure it. So there are four main levels of measurement. The first one is nominal, the nominal scale level, and that's qualitative data that is measured but can't be ordered. So nominal scale data can't be used in calculations. Examples of this would be favorite foods. Like if you listed your top 3 favorite foods without ranking them, you wouldn't be able to do anything with it. You wouldn't be able to order it. You would just have that data. Ordinal scale, the ordinal scale level is similar, but has one change to it in that this data can be ordered. It can be ranked, but the differences between the data can't be measured. So you could have, the top 5 national parks or survey data with answers like excellent, very good. So it's ordered, but it's not like the difference between excellent and very good is measurable. It's just a category. The interval scale level, that's data that is measured that can be ordered, and the differences between the data can be measured, but there's no starting point. So this data can be used in calculations, but ratio comparisons don't necessarily make sense. And temperature data is an example of this. There's no starting point. You wouldn't think like freezing, in your mind might be a starting point, but temperature data can get warmer than that, and it can also get colder than that. So it continues on forever. Ratio scale level, so that's data that's measured on a ratio scale. It's ordered, calculations can be made, and there's a starting point, and you can use ratios for comparison. So exam grades is an example of this. 0 is the starting point. You can't have a negative exam grade, and you can talk about the differences in exam grades, and you can use ratio comparisons. This grade was twice as much as the other grade. So here's a little table with those levels of measure and the different things that you can do with each level of measure. So for nominal, you can put it in categories, but you can't arrange it in order, you can't subtract data values, and you can't determine if one data value is a multiple of another. Ordinal, put data in categories, arrange in order, but can't subtract or talk about them being multiples. Interval then includes the subtracting, the being able to subtract the data values, and then ratio is the one that has all of those characteristics. So frequency. Frequency is the number of times a data value occurs. The relative frequency is the ratio with a fraction or proportion of the number of times the data occurs in the set of all outcomes to the total number of outcomes. I think I sort of mixed that all up. But basically, how many times that occurred divided by the total number of data points you have. So it gives you fraction or proportion or the percent that data item occurs. So divide the frequency by the total number of data points to get the relative frequency, and we can write them as fractions, decimals, or percents. So here's an example. 20 students were asked how many hours they worked per day. Their responses in hours are as follows: 5, 6, 3, 3, 2, etc. And what I've done is so this is from your textbook, table 1.10, and it has your data values listed from lowest value to highest value, and then the frequencies for each data value. And then there's a column of relative frequencies. And the way the book has it, it has the fractions, so 3 out of the total of 20, okay? Because there were 20 students that were asked, and so 3 of them worked 2 hours a day, 5 of them worked 3 hours a day, etc. So this relative frequency is 3 over 20. And if you divide that, that's 0.15. And then I added in this little column here, so that's 15%. The data value 3 occurs 5 times, or the relative frequency is 5/20ths, which is 0.25 or 25%, etc. So we're going to make this frequency table in Excel. So if you go to Excel now, or if you go to Canvas and you download the file that's there, the Excel file, it should say examples 1.3. And this is what you'll see on the frequency example tab. So I have listed the data here, how it was listed, the raw data. I put it in a column. It was in a row on the slide. And then I put in the data values 2 to 7 just to help us get organized. And then obviously on the slide in the table we have the frequencies and the relative frequencies. But I thought it might be helpful to sort of talk about how you would do it if you didn't have that done for you already. So tallies are tick marks, and when we do them with a pen or a pencil, we tick 4, and then we do the 5th one, we sort of diagonally go across, and that's like a little bundle, a space, and then we do it again. We can't do that in Excel, so for tally marks, I usually just do like 1, 1, 1. When I get to 5 ones, I do a space and then another one. Because when you're going through your data, you want to make sure that you keep it organized and figure out how many that you have. The other thing that we can do here, so like what I mean by tallies is, so here's a 5. So I would put a 1 in the 5 column. Here's a 6. I would put a 1 for the 6. Then I have 2 3s. So 1, 1 to represent those 2 3s. The next one, which is here, is a 2. So I'm going to put a tally here for my 2. And then I have a 4. I have a 7. And then I have a 5. So if you're going to put something in that cell again, you can just go up here and you can type it up there. So now that's not 11, it's 2 5s. And then I have another 2. I have a 3. I have a 5. I have a 6. I have another 5. I have 2 4s. I have a 3. I have another 5. And so now I'm at 5. So the next time I would want to put a space and start the next one. And then I have a 2. And then if I scroll down, I have a 5 and a 3. So I'm going to put a space here in my 1. And then I'm going to put this up here. And I just do that because I think it's easier to count. Each little bundle is 5. So those are my tally marks. So that means my frequency for my data value of 2 is 3. It is 5 for the data value 3. 3 for 4s, 6 for 5s. I had 2 6s and 1 7. And now what I'm going to do is I'm going to just add those up to make sure I got 20 values, because I should have 20 values. I'm going to use the Excel command equals SUM for sum. And then I'm going to highlight all of the data that I want Excel to add up for me. And I hit enter, and there's 20 data values there. So I know I got them all. So now what I want to do is the relative frequency. And first I'm going to do it as a fraction, then a decimal, then a percent. This table in Excel has way more than the one on the slide does, but I thought it would be helpful. So for our fraction, I'm going to type in 3 divided by 20. Okay. I can also see it changed it. It says 20 March. If you go up here, this is the format that our number or a cell has. I want it to be a fraction. So sometimes when it changes the formats, you have to go back in and retype it in. So 3 out of 20, it reduced it for me. But it does look like a fraction. So now you have to decide, do you want the reduced fraction, which this is an estimate, because 3 over 20 is not exactly 1/70th. And so what you can do is if you go to this little pop out here, number format, click it, and then see how it says fractions? It says up to 1 digit. I want up to 2 digits because of the 20. And then it says 3/20th. I am going to want to copy that format all the way down. So if I pull down like we did before, it's going to copy that number, but it should also copy the format. So now when I go in and I put in the other fractions, it should keep the format that I want. So 5 over 20, that one reduced because it reduces perfectly. 3 over 20, that's fine. 6 over 20, it reduced it again, but 3 over 10 is better than that weird one that we had before. 2 over 20 and 1 over 20, okay? So that's one way that you can do fractions if you want to see what they look like. So decimals. So again, notice up here my format is general. If I highlight this whole column and I go to the format, I can say, let's highlight it or format it as number. And then here we have different decimal options, and we're going to see what happens and what we get when we just type it in. So again, I could type 3 divided by 20, and I got 2 decimal places. That looks good to me. But if, say I wanted to do less work, I could do a formula. So I always start my formulas with an equal sign. And then I go over to my frequency and I say, let's take that number, that cell, and then divide, which is the slash, we've been doing that, by this number down here, 20. Or it's used the cell references to figure that out for me. When I hit enter, it does the division for me. And I can pull that down and it's going to fill it in for me. Now I got division by 0 because if you double click on this, notice it's doing some of the right things. It's pulling that 3, but then it moves down. Excel, when you pull down a formula, it moves down in the cells. So 2 ways to fix that. Up here, instead of saying F9, we can just type in that denominator. Then when we pull down, what it's done is it's doing 3 divided by 20. 6 divided by 20. It's referencing the cell. The other way to do it, and I'll do it up here when I do my percents, is I can say, okay, equals my frequency cell divided by the cell. But if you want to keep a cell from changing, you put dollar signs in front of the column and the row. So that will not change now when I pull it down. And you notice it's a decimal. We'll change that in a minute. So when I pull it down, it knows how to do it. The first number is changing, the first reference, but not the second one. All right, so now I'm going to highlight these and I'm going to go up here and I can click on the drop-down menu like I've been doing, or I'm going to just click on the percent. Now that looks good to me. If you want to add a decimal place, you can. If you want to decrease a decimal place, you can. There's lots of different ways to format your numbers. So these 3 here are my relative frequencies as fractions, decimals, and percents. Now, this should say CRF, so cumulative relative frequency. The cumulative relative frequency, I don't think we've talked about yet. So cumulative relative frequency is the accumulation of the previous relative frequencies. So what that means is that the cumulative relative frequency, the first one is the same as the relative frequency. The next one, we take the 0.25 and we add the one that came before it. Then we have a sum of 0.40 or 40%. To get the next cumulative relative frequency, we take that 0.4 and we add on the 0.15 from this row. So you're taking the current row and adding the one above it in the cumulative relative frequency. So it's getting bigger and bigger and bigger as we go down. And then at the end, you should get 1 if you're in decimals or 100% if you're in percents. So cumulative relative frequency has to add up at the bottom to 100% because you're accumulating it and you accumulate the whole thing 100%. Now, because of rounding, the relative frequency column may not always sum to 1 or 100%. It should be really close to it. If you rounded, when we're using Excel, we don't run into that quite as much because Excel can keep all of those decimal places for us, even if we're not looking at them. But if you get 75 or 92 even, you want to look back and think maybe you missed one. So we'll go back to the Excel sheet. There's the Excel sheet. And we're going to do the cumulative relative frequency. So cumulative relative frequency always starts out, and this is going to be my decimal column. So it's always the same as the relative frequency for the first one. Now what I'm going to do is I want to take the one that came before, the accumulating one, plus my new row relative frequency. So that's 0.25 plus 0.15, and I get 0.4. So now, because I use my cell references, I can just pull down and it does it automatically for me. So here it says, take my new one, 0.15, add the one that came before. Take my new one, 0.30, add the one that came before, etc. And you can see at the bottom here, my final cumulative relative frequency is 1, as it should be. Now, I'm going to copy these. I'm going to paste them here because they're going to be the same. What's different here is these are going to be percents. Okay. Now you can go through the steps we did before and use the percent column, and you should get the same thing that I got by copying and pasting it. So that's how you do a frequency table. So one thing that you could do too, if you didn't want to do tallies, and we looked at this before, my data here is not sorted lowest to highest or highest to lowest. It's all jumbled up. So if I highlight all of my data, go to data, we've looked at these options before. This time, I'm just with one column. I don't have more than one column. I'm just going to click A to Z, and it sorted it for me. Now I can kind of skip the tally part if you want. 1, 2, 3. I have 3 2s. I can just put it there. 1, 2, 3, 4, 5 3s. I can just type the number there. I wanted to show you how tallies work in case you want to use them, but you can also always sort your data and do your frequencies that way. So we are going to use this table, table 1.3, from Try It 1.4 in our textbook to answer some questions. So this table shows the amount in inches of annual rainfall in a sample of towns. So our first column is rainfall in inches. Then we have a frequency column, a relative frequency, and a cumulative relative frequency column. And you can see the counts. We have 50 towns, a total of 50 data points. Our relative frequencies add up to 1, and the cumulative relative frequencies add up to 1. So note all amounts fall between the endpoints of an interval and not at the endpoints. So you got to be careful about that kind of thing. And the way this table is broken up is nothing ends at the endpoint because it's in both columns or both categories. So our first question, what is the percentage of rainfall that is less than 9.01 inches? So you're going to look at your table and you're going to say, I want this frequency, this frequency, and this frequency. I want to add these 3 up, okay? So luckily for us, that is the cumulative relative frequency to get to 9.01. So our answer here is going to be 0.56 or 56%. What is the percentage of rainfall that's between 6.9 and 13.05 inches? So now we're in the middle of our table, and we have this row here, and this row, and this row. We have these 3 middle rows. So we want to add up 0.3, 0.16, and 0.18. Now I'm going to go back to our Excel sheet because I put this data in here for us. So we know from the first one that this is going to be equal to 0.56. I don't really need the equal there, 0.56. I got that from here. Or I could do a sum formula, and I could say add these 3 up, and I get my 0.56, and then I can put it in percent. Oops, I wasn't in the right cell, percent. And now for this one, the rainfall between 6.99 and 13.05, I can just take a calculator. I can add these 3 numbers up and I can get what I want, or I can have Excel do it. So equals sum, double click if you want, and highlight the numbers, the columns, the rows, whatever it is you're trying to add up, highlight those. So between 6.99 and 13.05 are those highlighted cells. I get 0.64 or 64%. Now this one is, if we go back to the slide, so that's the percentage. The next question says, how many towns have a rainfall between 2.95 and 9.01 inches? So now we want to count. We don't want to add up the relative frequencies. We want to add up the frequencies. So we're going to do another sum. We're going to go between 2.95 and 9.01 inches. And we're going to get that 28 towns had rainfall between those two numbers. And then what fraction of towns surveyed get between 11.03 and 13.05 inches of rainfall every year? Same thing. Oh, so 11 point, yep. So it's these two here. So you could do that by hand, right? Or it's just going to be 0.28, I believe. Okay. Equals 0.18 plus 0.10 gives me 0.28. If we want the percent, we can just change it to percent. All right, so that's a couple of different ways to do it. Oh, what fraction? I knew I was like, it's like I got something wrong. All right, so let's change this to fraction. 2/7. Now let's make this up to 2 digits. And we got 7/25 because I'm going to redo this one. So because I want between 1103 I'm not sure why it didn't show up the way I wanted it to. So we're going to do this 2 different ways. So sum here, and it's my slide has 9/50, but like, oh, because I'm so, please forgive me. It's just 9/50. They don't need a sum here at all. All right, so 9/50. There we go. There's our fraction. I was thinking I was adding up those 2 rows. I apologize. All right, and again, you can do your fraction format and do it with the 2 digits if you want. All right. So here's our last example. Try at 1.8. This table contains the total number of fatal motor vehicle traffic crashes in the United States for the period from 1994 to 2011. So I took this data out of the textbook and I put it into Excel along with these questions. So if you go back to Excel to that final tab, what you'll notice is I took the data because it was in 4 columns, and I just put everything in one column, all the years in one column, all the crash numbers in the other column, because that just made it easier when I was doing my sums and my formulas and my frequencies and all that stuff. So we want to go through and answer the question, what is the frequency of deaths measured from 2000 to 2004? What percentage of deaths occurred after 2006? What is the relative frequency of deaths that occurred in 2000 or before? What is the percentage of deaths that occurred in 2011? And what is the cumulative relative frequency for 2006? And explain what this number tells you about the data. Okay. So relative frequency. So we have at the bottom a total number. So that's going to come in really handy. So our relative frequency, I'm going to do a formula. I'm going to do equals this number and divide by. And again, you can just type in your total number, or you can do the $ column, $ row number so that doesn't change when we pull our formula down. Either way is fine. So if I do this, then I just want to go up here and type in my $ so that the row and column reference doesn't change. There's my relative frequency for that one. I'm going to pull this down and it auto fills it in for me. If I pull it down all the way, I should get a 1 at the bottom because I'm dividing it by itself, so I don't want that. And you can decide to display your relative frequencies either as decimals. Maybe you want to have fewer decimals than that. Okay, you probably want to have at least 3 or 4, or you can have percents, but then you would want to increase the decimals so you have more specificity in those numbers. Totally is up to you to a certain extent. So I'm going to have 4 decimal places, and I'm going to keep them as decimals. And then cumulative, remember, we're going to add the one that came before. So this one is always just the same as what the relative frequency is. And this one is where we do the one before plus the new one. We're not doing the dollar signs because we want those references to change each time as we go down. So now we are going to pull this down, and when we get to the last one, we should get a 1. So that's good. So we now have our relative frequencies, our cumulative relative frequencies, and they're both in decimals. So looking at my questions, everything's actually in percents. So we can leave them in decimals and then do percents at the end, or you can do percents now. So what is the frequency of deaths measured from 2000 through 2004? So I am going to do a sum. So this is the percent frequency. So I am going to do equals sum and 2000. Make sure you're in the frequency column through 2004. Right, and I'm going to turn that into a percent. Maybe I'll give myself 2 decimal places, a little bit more than 29%. And so on the slide, what I did is I put in all the math, like what you're adding up together and dividing by, and then giving you the 29.2% answer. So if you were going to do it by hand, you would add those numbers up and then divide by the total to get that answer. What percentage of deaths occurred after 2006? So I'm going to do my sum. I'm going to go after 2006. So I'm not going to include 2006. I'm going to do 2007 to the end. And I did the frequencies instead of the relative frequencies. So let's change that and do, I could have just divided by the total at that point, but let's do the relative frequencies. So 2007 and through the end. So why did I get a 0? Because it is a small number. So, and I must have had like reduced the decimal points for that. So we're going to do a percent. So 25%, it's 24.86%, 24.9%. So the percentage of deaths that occurred after 2006, 24.9%. What is the relative frequency of deaths that occurred in 2000 or before? 2000 or before. So before 2000 is going to be 94, and it says or, so 2000 or before, so I'm going to include 2000. You always want to really try to, look, I did it again with the frequencies and not the relative frequencies. You always want to read your problems carefully to know if you're including something or not including it. Inclusive or exclusive of a row, a number, a data value, whatever. All right, so now we have 0.3978 as a percent, 39.8%. I think on the slides I did just to 1. What is the percentage of deaths that occurred in 2011? So just the percents in 2011. So that is just going to equal one of our, is it just, yep, in 2011. This one cell, and make it a percent. Give me some more decimal places, 4.5, 4.6%. And then what is the cumulative relative frequency for 2006? And explain what this number tells you about the data. So the cumulative relative frequency for 2006. So that equals, let's find 2006 here, this number here. And as a percent, 75.14%. So what that means is that a little more than 75% of the deaths occurred up to and including 2006. All right, so only 25% of the deaths, a little less than 25% of deaths occurred after 2006. So answers and rounding off, we sort of touched on that a little bit. You know, we were looking at those things and adding decimal places, decreasing decimal places. You want to round your final answer to one more decimal place than your original data. Don't round your intermediate data when you're doing sums and all sorts of things. You want to carry them to, you want to keep all the decimal places if you can, and if you can't, carry them to twice as many decimal places as your final answer is going to have. For example, the average of the 3 quiz scores, 4, 6, and 9 is 6.3. So we round that off to the nearest tenth because the original data was whole numbers. And in general, you don't need to reduce fractions, and often the unreduced fraction is more informative in this course. I mentioned that before. Excel doesn't always make that easy for us because it automatically reduces them if it can. So you just have to keep that in mind, depending on what your problem is asking you to say. So if you have any questions, please let me know. That's my email. You can always send me an email, ask me a question, and let me know. Okay, thanks.